Hello everyone. So starting with part D now, it says for 0, where t is in between 0 and 8, is there a time t when the rate at which the water is being pumped into the tank is the same as the rate at which the water is being removed from the tank? Okay. So the question is there a time t where R of t is equal to W of t? Okay. So the reason why I say this is probably a this is a theorem's question is like they're asking about an existence of a time t. So I'm probably going to use, like I said, IVT or MVT, because we're talking about when they're equal to each other, right? So it's not talking about the existence of a max or a minimum value, which would hint to use EVT. I also know that when I'm like, okay, is there a time where this is true, right? So in other words, it's asking, is there a time t where W of t is equal to R of t? So if you knew what the function R of t was, like if you didn't just have a table of values, then of course you could use your graphing calculator to graph both functions and find the intersection. Okay. So I'll note that to here. So if you had the function R of t given in the problem, then you could graph both functions and find the intersection. Okay. So you could graph both functions and find the intersection. So that would kind of, that would be a way of how you could find t. Now, of course, they didn't give you R of t. They just gave you a table of values and told you what R of t was representing. And so that's why we're like, okay, we probably have to use a theorem of some sort. Okay. So I'm kind of stuck here in terms of, finding when they're equal to each other. I mean, there's no derivative involved per se yet, right? It just, because you're really trying to answer when W of t is equal to R of t. So since there is no derivative in this equation, I'm not really thinking MVT. I'm trying to think of how I could really use IVT. So I'm thinking, how could I use IVT? Right? Which says if f is continuous on closed AB, then there exists a C where f of C is in between f of A and f of B. Right? So there exists some value C in between A and B such that the function value is in between f of A and f of B, like the endpoints. Okay. So then you're like, all right, well, then there was also like this kind of corollary, so to speak, or it followed, right? That if f of A and f of B have opposite signs, then there exists a C where f of C is 0. Right? So those were those two things for IVT. The straightforward and then kind of what follows from that, because of course if f of a is negative and f of b is positive or vice versa, then your f of c, of course there is going to be some point where there exists a c where f of c is equal to 0, because 0 is in between a negative and a positive value. So now you're like, okay, how am I going to use that, right? Because we're talking about when two functions are equal. Well, if you think about it, we're really trying to answer, does there exist a t where this is equal to 0, right? If I subtract r of t from both sides. So does there exist a time t where this function w minus r is equal to 0? Well, if I can use this corollary that says if they have opposite signs, so if w of 0 minus r of 0 and w of 8 minus r of 8 have opposite signs, then I know that there exists some value t where this is true by the IVT, right? But I do also need to show that w and r, are continuous, which means that when I subtract them, they're continuous, right? So let's look back and just, look and see if these functions are even continuous. So w is definitely a continuous function by looking at it, right? I'm not breaking any math laws here, because even in the exponent, we're dividing by 20, so that's never going to be undefined at any values of t. So that's a continuous function. And then r of t, it says it's differentiable, so I know it's continuous. Okay. So how I would start this, I'm going to use a different color. So since w of t is continuous and r of t is differentiable, which implies that r of t is continuous, then w of t minus r of t is continuous. Okay, so the first condition of using IVT or any of the theorems is met, right? Because we know that these two things are continuous, and when I subtract them, it's continuous. Okay, so then I also have to check now the signs of w of 0 minus r of 0, right? So also w of 0 minus r of 0 equals, something, and then w of 8 minus r of 8 equals something. And as long as those are opposite, we would have, so by IVT, there exists a time t where w of t minus r of t equals 0, which means w of t is equal to r of t at time t. Okay, so yeah, so I'd have to actually just check what w of 0 and r of 0 are. So of course I'm going to plug in 0 into that, so I get 2000 e to the negative 0 squared over 20 minus r of 0, which is 1340. So this should be positive. This should be bigger than 0. And then W of 8. So this is going to be 2,000 e to the negative 8 squared over 20 minus whatever r of 8 is, which is 700. I'm guessing that this is negative. And so then that means by IVT that there exists this. Okay, so that's pretty much how you would show it out. Let me just make sure I have the right signs based on the guidelines. Yep. So yeah, W of 0 is positive and W of 8 is negative. Of course, you'd find those actual values using your calculator. I just didn't have my calculator on me. Okay. So yeah, it was important that if you had said, I mean, it depends on the guidelines each year, but the fact that you, I guess, considered the WT minus R of T to begin with would give you a point. Most likely now how they grade these is not only considering it, but also saying that explaining why WT minus R of T is continuous is a big part of the exam now. So it, use just the beginning part of this right here would definitely have gotten you a point or two. And then moving from there, showing that they're opposite signs and showing it's by IVT, that would give you the remaining points. However, this is weighted.